Okay, let's try this again. So in the last video I made, I was talking about the tangent line. We were talking about the slope of the tangent to the curve, the derivative, but I never really expressed exactly what the tangent is. So today I just want to talk about, like, the aim should, it's not a full lesson, this will be like 6 minutes. The lesson should technically be something like, what exactly is a tangent line? Now, you know the word tangent. You know the word tangent from trigonometry, and that was you learned that was sine over cosine. Let me see. Yeah, let's get that up. Here we go. Yeah, you learned that as sine over. So let's see. Sine theta. Do I have a theta here? Yes. Over cosine theta. So that's what you know tangent as. Maybe for sine and cosine, you learned it as what else? You learned it as like opposite over adjacent, and then you learned it as it became sine over cosine. That was the first definition. The second definition you got was at the end of the geometry unit. At the end of the geometry unit, where you actually have. So let's see. The end of the geometry unit. Oops. You actually learned it as a line that just touches a line that touches the circle at one point. And so, you learned it as, you learned it as, that's what you learned a tangent as, a line that touches a circle at only one point. You also learned in the class that this is a tangent. Oh. Yeah, you learned that's the tangent. You also learned about something else in the geometry class called a secant. And that a secant was a line or a segment that crossed the circle in 2 points. So this is known as a secant. Now, just to connect from last class, let's go to let's see if the Desmos is still there. Oops. Let's see if the Desmos is still there. Some of you might look. Some of you might say, well, Mr. Adler, in yesterday's lesson, we did have that cubic. We looked at the cubic, and we were putting like the surfboards. Let's see if I can get a segment here. Here's a tangent line, but then someone might say, hey, Mr. Adler, sorry, you're perfect. Here's a tangent line. Someone might say, hey, Mr. Adler, this line, if I extend it, it might intersect the curve at a second location. So this tangent line touches the curve in 2 points. So let's change our definition a little bit and say the tangent. Let's say the tangent is a line that intersects the curve, but locally at one point. So the idea is, like, I'm getting really close. I'm getting really close, like right here. Imagine taking a microscope and zooming in right there. You're zooming in, and you want to see what's going on in there. So you get really close to that point. You see the tangent line at that local point only touches the curve in 1 point. Now, the next thing I want to do is I want to connect this idea of this ratio to this actual physical line. So what we're going to do is I think when I move this up, I'm going to erase everything. Let me just move this over. I want to move the curve over, and because I want to, yeah. Okay, so what I'm going to do is I'm going to put the graph in rectangular grid, and then what I'm going to do is I'm going to put a circle here. Let's assume that it's a unit circle, okay? The next thing I'm going to do is I'm going to put a rotation. I'm going to put a rotation in here. So that's our segment. Let's construct a segment. And then I'm going to draw the perpendicular down. Let's get it. And so we know this line. And so we say, okay, we remember this was y, this was x, this was sine, and this length was cosine, and the length of, because it was a unit circle, the length was 1. So what I'm going to do is first I'm going to change the color. I got to figure out how to do this without I don't think I'm getting this right, but I'll figure it out one day. I'm going to make it light blue. Nope, that didn't work. Let's try it. There we go. Let's put this back to red. Okay, then what I'm going to do is I'm going to extend this line up, and then I'm going to drop the perpendicular. Sorry, I'm going to drop the perpendicular right to this length here. So the question, it's clear I have two right triangles, and they're similar because they all have the same angles. So I can do a comparison. I can say they're similar, therefore the ratio of corresponding sides are in proportion. I'm going to call this new side, let's just call it T. For nothing in particular, you know what it is. And so let's make the ratio. So we know it's sine over cosine is equal to this T, what I don't know what T means, over this length down here, the base of the big red triangle. That because it's the the radius, it has a length of 1, and you say not a coincidence that T is tangent. So this length represents the tangent of this angle. Well, it's not look at this segment. This is an actual physical tangent to the circle, and that's the connection between the tangent, sine over cosine, and the actual physical sense of a tangent. And that's the end.